All right, for the last presentation of this session, we're going to have the GIS-based BMP compliance management application. And Randy Trott from Timmons is going to be presenting this. He's a principal with Timmons, and he's provided overall technical management for Timmons Group for the GIS projects, which include enhanced 911, tax parcel mapping, utilities, GIS applications, and any other computerized mapping. And just another side note, after this session, lunch will be served in ballroom C at 12 o'clock. Randy. Thanks, Sean.
Good morning. Thanks for attending. Hopefully everyone got here safe today. My name is Randy Trott. I'm principal with Timmons Group. I'm going to talk about principally stormwater, BMP, and illicit discharge applications that we're working on in Virginia. That is becoming a more and more relevant topic, not just in Virginia, but anywhere where federal guidelines and federal regulations are coming into play. We're going to look at two applications today and actually touch on a third. I may or may not jump into a demo here depending upon time. In Virginia, the MS4 requirements that are coming down are pushing specifically the burden down to the local levels. So those MS4 localities are the ones that are going to be responsible for the compliance, the inspections, and ultimate reporting back to the Department of Environmental Quality. So we're going to talk through that. We're going to look at a couple applications that are scaled to meet client needs, and hopefully answer any questions you have at the end. Again, MS4. What is an MS4? It's a municipal separate storm sewer system. These are heavily regulated, or becoming more heavily regulated at the state level in Virginia and North Carolina. Virginia made the move from putting the onus on the state to manage this to putting the onus back on the localities. So any MS4 locality in Virginia is responsible for this compliance reporting. MS4s come in two distinctions in Virginia and elsewhere. There are large or phase 1 MS4s, and those are generally over 100K population. There are also phase 2, which are considered small or medium, which are under 100,000 in population. MS4 burden also falls on not only localities, but sometimes colleges and other managed public areas. So there's a real need to start formalizing this in the community. So our strategy for addressing the needs. Typically what we're seeing is on the smaller localities, the phase 2 localities, they're not actually doing the inspections. They are either engaging the owners, if it's a private BMP, to inspect that BMP, or they're engaging local engineers to do those inspections and report on the compliance. What they do need are the tools to help facilitate and support that compliance and record tracking that's required with the DEQ. The phase 1s, typically they are doing their own inspections, so not only any public BMP owned by the municipality, but also the privates, they will go out and as a part of their MS4 program, will do those inspections. What we've chose to do is look at these two types of entities differently. The phase 1s, we're looking at inspection and compliance applications that are mobile and web-based. And the phase 1s, because they typically are small, but they do have access to ArcGIS, we've decided to go the desktop application approach. So we've written some ArcGIS add-in technology to 10.2.2 to help support that program. We're also looking at leveraging CityWorks where applicable. Any municipality with CityWorks that has these requirements, BMPs are just another asset. So we would add that asset into their framework of management and track those inspections as we would any other asset that they're currently tracking. So those are kind of the three levels of technology that we're employing for BMP and MS4 management. We have a case study here. I'm going to go over the town of Ashland. Town of Ashland bills itself as the center of the universe. I'm not exactly sure why, but probably only when things are going well they bill themselves that way. The objective here is to build an Esri geodatabase model that supported the migration of some existing tracking they had. They had some access-based information that they wanted to bring forward, but it needed to be compliant with the latest and greatest that Esri has to offer. So what we did in that case is customized a solution, an ArcGIS add-in built with ArcObjects. Again, it's running on 10.2.2 at the moment. It does support overlays, so any ancillary information coming from the state and federal level, that can be drilled down into to help support and populate the information that's required for the reporting. So we're aggregating state, federal, local information as well as base map imagery either from Google Maps, Esri, or whatever sources are available. On the desktop application side, we have some very specific things that are requirements. Geographic location, so they want a latitude, longitude. They want HUC zone 6th order boundary information to comply with that. They want the latest, or excuse me, the closest impaired waters information associated with that record. They're also interested in whether it is in compliance, whether it's passed, what the inspection intervals are, what the overall inspection tracking is. They're not so much interested in the inspections themselves, but the reporting behind whether they've been done and whether those BMPs are in compliance. So in order to do that, we engage the customers. Typically, we look at their workflow. We start establishing the model that's going to support this. Many of the communities have organized their information by projects. So a project would be a site. It may be a subdivision. It may be commercial development. And there may be multiple BMPs associated with that project. So there's a single project, maybe a single owner, maybe multiple owners, and there may be multiple BMPs associated with that project site. So all of that relationship, classing, and domain information, all that's put into the geodatabase model to help support and manage that one-to-many relationship that we're typically finding with the BMPs. So here's an example of the physical design for these BMPs. Again, I mentioned, I'm going to go out on a limb here with the pointer. We have the project site, essentially the location. We have the owners. We have the physical features, i.e. the BMP assets. And we have these relationship classes in here. This is all structured in the geodatabase. On top of this, we have maintenance records. So these are recurring records that happen on 1, 2, 3 year intervals. And we have compliance records. These sort of roll up by project site, whether one or many BMPs are in fact complying with the inspection and the regulations. Everything possible that we have domains and subtypes for, we're actually also leveraging that as well. And here's an example of some of the domains on the information. In Virginia, there are old and new domains for BMPs as of, I think the cutoff was 1999. They reformulate, reconstitute what they call BMPs. So they have old and new classifications. That's all fully supported in domains, as well as some of these other things that are very device or asset specific. So again, the phase 2 localities, the smaller ones, they are most interested in the compliance dashboard. Again, this is an ArcGIS 10.2.2 add-in that's been developed. The compliance dashboard allows just a quick summary of what is pending as far as due inspections, past due inspections, and any maintenance activities that have been identified as being required for that BMP to come into compliance. It's all geodatabase driven. Again, ArcMap add-in. The way Esri manages relationship classes, this does require ArcGIS standard to be able to do this editing. Any relationship class within the Esri environment is not capable of being done with ArcView or ArcGIS Basic. So one part of this compliance reporting, the state's looking for, on an annualized basis, information on each BMP when it's been inspected. Again, some high-level information about that BMP that's rolled up by each MS4 community initially in the Chesapeake Bay managed areas, but also the MS4 boundaries or communities that are outside the Chesapeake Bay areas. We've added some graphing and basically summary information here. This gives us a quick snapshot of BMP type, the number of BMPs in that particular locality, just so they can have a kind of a quick visual on what they're dealing with and what their typical BMP asset is going to look like. I'm going to shift gears and we're going to take a look at Prince William County, Virginia. It's a BMP mobile web application for BMP inspections, tracking, and illicit discharge inspection and tracking. Prince William is, I guess it's a suburb of DC. It's probably 300 to 350,000 in population. This does fall in the category of having a very large managed stormwater group. A lot of localities are going towards stormwater utilities, so these are the type of things that these localities, these larger localities, are actually leveraging more and more. We're finding. So anytime we engage on and this is a customized solution that can be adapted, but anytime we engage any entity on a project, we try to look at the value propositions. We try to ensure that those align with the application's development, and overall, trying to achieve the successful, why are we doing this kind of thing. It's pretty important to get that defined up front and make sure the gaps are covered. So this thing's right now in a beta environment. We're developing a desktop web app for managing the administrative side as well as the inputs coming from the field. There's also the mobile piece. We have illicit discharge, which typically involves outfalls, as well as facilities, which typically is a BMP or some sort of structured asset. And again, we have that information collected in the field. It's rolled up from that tool into the website, and that information is collected, managed, and ultimately reported back to the state. So this has a user administrative portal to add, manage, delete, access, delete users. Projects can be created here, so if there's a new development, that's all created on the website. This is a pretty significant number here. There's 1,700 project sites in Prince William County, meaning there's at least 1,700 managed BMP facilities. The dashboard's going to allow users. This is the mobile solution. It's going to enable users to see what the activity is out on the ground. and look at things in a sort of a colorized sense of priority. So information on it, whether it's assigned to a particular inspector, whether it's overdue, whether it's close to being pending, or whether they've got a little bit of time. That's all, again, colorized on the mobile solution. The mobile solution that Prince William chose was an iPad application. It can be run on the iPhone as well, but generally the design is going to fall into this concept of iPad. The development is done in native iOS, so typically what we're finding is instead of HTML5, if a customer has a very specific platform, we can build more robust applications if we're targeting toward that particular platform. So in this case, it is a native iOS solution. The inspectors have the ability to view information, add activities, do the inspection information, and add photos. So that that solution, that scenario is all captured and managed in the field. We're talking to them right now about the ability to do compliance reporting and compliance notification right now. So inspection notices. If you're out there, you find something wrong, be able to print that out on a mobile printer and hand it out or email it from the field. Same thing with violation notices. If there's some sort of activity or either illicit discharge that's found or a BMP that's not in compliance, to be the ability to hand that out instead of going through the bureaucracy of sending from the office, just do it right there in the field. Cut out the steps. On the web, once that information is collected, it can be edited, it can be re-edited, just again managed a little bit more effectively using that web app. Reporting, the state is interested in, again, some nominal information about these activities. So this is customized to support input forms the state has. It's typically driven by Excel or CSV. So that information is exported out into that format and can be uploaded into the state's portal when that information is ready. I'm going to give this a shot real quick. All right, so this is the web portal. The web portal. Oh, am I?
Yeah, I got you.
All right, thank you. Yeah, sorry about that. And now I can't see it on here. So this is the web portal. Again, this is where assets or projects are assigned, managed. Information that's coming in from the mobile devices is collected, analyzed, and ultimately reported. We have some capabilities to look at outfalls, which again are typically aligned with illicit discharge, as well as BMPs, look at details on that information, manage, edit, delete. Prince William's looking at a fairly comprehensive inspection. Again, all this is controlled and domained. There's a combination of technologies. Let's see if I can get back to that screen. It's a combination of technologies that are being leveraged here. I mentioned native iOS, so there is an Apple component. We typically will we don't use a lot of Esri client on this type of application, but we are using our GIS server on the back end. So in this case, what I just showed you, that was back in our development environment at Timmons Group. More and more, we're for sophisticated clients, this could be hosted at the locality. It could also be hosted in the cloud. More and more of our hosting solutions are going to be Amazon-based, where we've been through a few different iterations on that, and AWS seems to be where we're ending up with our hosting solutions. I mentioned CityWorks. Timmons Group is a platinum partner with CityWorks, so we have a lot of clients. We have several in North Carolina that are deploying this for a public works or public utility scenario, as well as private utilities. CityWorks, what we envision here is the same concept, the ability to do inspections in the field, pull that information in to the CityWorks environment, and manage this as any other assets managed. Essentially, it's just another piece of data that lives in that geodatabase, and CityWorks is able to manage pretty much anything out there. So conceptually, that's where we're heading with this. Again, for the folks that have signed on to an enterprise asset management system, this is our approach to helping them manage these new unfunded mandates that are coming down. Just a few thank yous. I'm not going to go through that. That's the presentation. Appreciate your time. Any questions?
I have a question. With the Ashland example you showed us, why did you, most of the data is actually not the spatial data that you're interested in. I mean, there's the where is it located. Once that's set, it's not like it's changing location. So why did you go with the geodatabase as the back end as the storage?
Good question. We actually did a lot of the collection using our GIS collector for them. One of the requirements is the ability to collect that latitude, longitude. It's more a function of if there's anything, if it's a large subdivision and that's considered a project, anything new added onto that and managed. Probably the most important reason we're managing it in a geodatabase is we can get that spatial query capability. So we're drilling down into the HUC zones, we're drilling down into the localized watersheds. If you have a sophisticated drainage network, you can also look at that in paired waters, see where things are, do trace backs to see where that BMP may be draining to. So that geographic context is important. It's less important the less robust your data is, but it's much more important if you want to do, some of that, what GIS is good at, that spatial query type stuff. Other questions? All right, looks like you're getting lunch early. Thanks for your time.